at x equal to 0 to x equal to L. The intensity of this point is at x equal to 0 is 0 and at x equal to L is W0. L is called as span. So where is the center of gravity of this one? Is it at distance of L by 3 from the left 90 degree? So center of gravity is the distance of L by 3 from B and 2L by 3 from A. And the total load equal to area of the triangle which is acting downward through the point G. So this is total load is just nothing but the area of the triangle, that equals to half base into height. We want to compute any load at any distance x from the end A. Then this load value y is equals to W0 divided by L multiplied by x. Is it correct? At point A, x is equal to 0, so your load is 0. At point B, your value of x is equal to L, so W0 by L into L is equals to W0. So at any distance x from point A, your intensity of the load is W0 divided by L multiplied by x. Using this one, we can find out reaction. Using second figure, we can find out reaction. And this figure we'll use to construct the moment equation and the shear force equation. So we have a simply supported beam AB carrying a uniformly varying load from point A to point B, and the span is equals to L. So reaction of this figure is calculated from this point, from this figure. That is the only use of this figure. To find out the reaction AY and BY, we take the moment about A and then we take the moment about B and we'll equate to 0. So what is the moment about the point A? The 1 by 2 W0L will make a clockwise moment at distance of 2L by 3 from point A, and B will make a moment equals to anti-clockwise at distance equals to L. We'll equate this and we'll find out the reaction BY. So what is the value of BY? So the reaction at point B is BY is 1 by 3 W0L. Second reaction you can find out by equating the sigma Fy equal to 0. So if we substitute sigma Fy 0, AY is positive, BY is positive, minus 1 by 2 W0L, and if we put for BY, we'll get reaction AY equals to W0L by 6. That's fine. Now let's write this equation, reaction on the original figure. So we have W0L by 6 and we have 1 by 3 W0L. The reactions at 2 points. Now we will construct we will use this figure number 3 now to construct Vx and Vy, to construct the shear force at any distance x and to find out moment. So let's consider the section is at this point only. So what is Vx? Is the value of Ay. So this is AY minus this total load. This total load is 1 by 2. That is the area of triangle. Distance is x and the intensity is W0 multiplied by x divided by L. So that equals to AY we have written W0 multiplied by L divided by 6 minus it's W0 multiplied by x square divided by 2L, and this represents the equation of parabola, and the parabola is downward parabola. Agree? Because Vx is proportional to minus x square, so this is downward parabola. So at point A, x is equals to 0. So what is the shear force at point A? Is it equal to W0 L divided by 6? So at point B, substitute x equals to L, and in the equation number 1, that is this is equation number 1, substitute x equal to L and solve for Vv and check your answer is minus 1 by 3 W0L. Agree? Observation, what is the shear force at A? Is it a positive value? and is the shear force at B is negative value. इसका मतलब shear force में sign change हो गया, and therefore there must exist one more point in between A and B where shear force equals to 0. Let's say that point equal to C, and what is the condition at C? The value of shear force at that point will be equals to 0. Agree? So to find the value of the point C, the shear force will be equals to 0. Substitute in equation 1, the right hand side equals to 0. So W0 L by 6 minus W0 x square by 2L equals to 0. And what you get is W0 is cancelled, L square will become, and it's L square divided by 6 divided by 3, no? Divided by 3, is it equals to x square. So value of x is equals to L by root 3. So at this point your shear force will be equals to 0. If the shear force is 0, bending moment will be maximum at that point. So first of all, we'll move upward. We'll start the shear force on the left hand side. We'll move upward with a value equals to W0 at this point. This one is W0 L by 6. And we have a parabola. Parabola is downward. So this is downward parabola. At this point equals to 0. So what is this distance? Is it L by root 3? And what is this value? So this is shear force at point B, which is equals to 1 by 3 of W0 into L. This is negative value, and the reaction at this point is 1 by 3 W0L, so it will come to 0 again. So shear force diagram is complete. Start collecting the moment equation, and moment equation we will write down from Vx equation. So if you multiply Vx by x, you will get your moment equation. So if you refer to the figure number 3, what is the moment of RA, that is AY? Is this moment is a clockwise moment, and is the distance of this AY from point A is x, so that is positive quantity. Now this triangular load has what area? Is it 1 by 2 x times y? Correct. And what is the CG of this load? Is it here? And is this distance from this point will be equals to x by 3 minus 1 by 2 x into y is area of triangle, and the distance from section AA, the distance from section AA is x by 3. Now substitute and write the complete equation. So moment at any section x will be W0 L by 6 into x minus 1 by 2x, and y will substitute from this equation W0 L by W0 L into x and value of x by 3. Now this will become cubic equation. So you get moment about x is equals to W0 into L into x by 6 minus 1 by 6 W0 x cube by L. So this is negative parabola. Now let's calculate this about the point A and about the point B first, and one more point is point C here. इतना तो स्टैंडर्ड निकालना ही पड़ेगा आपको. For simply supported beam, the bending moment at both the point is 0. So there is no need to check at point A and no need to check at point B. It always equals to 0. Now what left is the bending moment about point C. So for point C, you have to put x equals to L by root 3. And what is this bending moment? Is this bending moment is the maximum possible value. इसमें substitute करना है. So this one is W0 multiplied by L by root 3, and this one is 6 minus 1 by 6 W0 by L, x cube is L cube, and cube of root 3 is 3 root 3. Finally, we got maximum bending moment at point C. So this is the bending moment at point C, and is W0 L square 9 by root 3. Now check, what is the bending moment at point A? 0. What is the bending moment at point B? 0. And in between A and B there is a point C also, and is the bending moment for that point is also equals to positive value. It means that the bending moment is positive throughout. and is in the form of cubic equation. And this maximum bending moment will occur at distance of x equals to what? L by 3. So let's construct the bending moment diagram. So bending moment at point A is equals to 0. Bending moment at point C is maximum and is W0 L square by 9 by root 3, and bending moment at the point B is equals to 0. So we have a simply supported beam and we have a two triangular load with a maximum load of 10 kilonewton. Is it also point load here? 10 kilonewton is total load. Is it correct? अच्छा, इसका total value कितना हो जाएगा? 10 into 3 1 by 2 मतलब 30 15 plus 15. ये ट्रायंगल का लोड कितना है? This is 10 value ना? 10 into 3 30 और half 15 plus 15 30 plus 10 40 का half 20 and 20. Correct? We will not consider 10 now. We will only consider two triangular load. So what is the area of this side? Is it 15? And what is the area of this side? Is it 15? So 15 plus 15 30. So reaction is 30. Is it equally distributed because of symmetry? So this reaction is 30 as well as this reaction is also 30. Reaction is 15 on both sides. Consider the figure number 3 and we have a reaction because of symmetry equally distributed is 15 kilonewton, and we consider section AA. Now we wish to write the moment equation and the shear force equation. The shear force at any distance is 15 minus 1 by 2 xy. So minus 1 by 2 x and y is W0 by L into x. For this load, that is a triangular load, W0 is equal to 10 and L is equals to 3. तो ये कितना हो जाएगा? This equals to, so the shear force at any distance is given by 15 minus 5 by 3 x square. But is this equation applicable only for AC? Is this equation is applicable only for AC? So we will only construct for AC and then the remaining part will be mirror image. So what is the bending moment at point A? Is it 0? Sorry, what is shear force at point A is 0. Can we calculate at point C by putting x equal to 3? Can we calculate shear force at point C? Okay, for A we'll put x equal to 0 and for C we'll put x equal to 3. Chalo. So we have at A x equal to 0, the shear force is 15. At C x equals to 3, so shear force equals to 0. The shear force diagram is proportional to minus x square is a downward parabola. The downward parabola will be like this. Left hand side will not come in the picture. So this is a parabola of second order degree, and finally we close at 0. So this also equals to what? Minus 15. So we have degree equal to 2. Now we'll calculate the moment about point x. So mx equal to 15x minus 1 by 2 xy into x by 3. इसमें सब्स्टिट्यूट कर दीजिए, चेक करें कितना आता है आंसर. So 15x minus 1 by 6 x square into 10x by L. ये और सॉल्व हो जाएगा. Finally we have moment at 15x minus 5 by 3 x cube by 3. If it is simply supported, is the moment at A and B always 0? And where the shear force is 0 is the bending moment is maximum. So we have a shear force at point C 0. So we'll substitute C at C x equal to what? 3, and we'll find out maximum bending moment. Now is this again a cubic curve with a negative power? Maximum bending moment is 15 into 3. Our limit is from 0 to 3. Minus 5 by 3 into 5 cube by 3. What is this answer? The value of x is 3, so this is 3 cube. What is this final answer? See how I am constructing the diagram. Is the bending moment at this point is 0? And is the bending moment at this point is also 0? You are sure about this? And is this bending moment is positive? Correct? If I join this point, this point, this point, is it a downward parabola? If I join this point and this point, is it downward parabola or downward cubic parabola? Correct now? So it's a minus x cube, means the parabola is downward. So even if I draw it on this side also, it doesn't mean that a parabola is positive. It's a downward parabola. Is it correct? And what is the maximum value of bending moment? Is 30. Okay, we'll handle this case. यहाँ पर एक बेंडिंग मोमेंट लगा है, लेकिन उसका इंटेंसिटी कांस्टेंट है, कहीं पर भी उसका वैल्यू m है, एंड दिस इज कैंटिलीवर. मतलब यहाँ पर भी m है, तो फिर यहाँ पर m है, तो फिर यहाँ पर टोटल कितना हो गया 2m, फिर यहाँ पर m है, फिर यहाँ पर m है, फिर यहाँ पर m है, तो टोटल कितना हो जाएगा ml. यहाँ पे m है, फिर और एक m है, ऐसे कितने बार करना है? तो l बार करना है. m फुट बेंडिंग मोमेंट है. जैसा यूडीएल होता है ना अपना, तो यूडीएल में हम क्या करते हैं? एक एरो लिया w, दूसरा एरो लिया 2w, तीसरा एरो लिया 3w, तो w0 को हम रिप्लेस कर देते हैं. ऐसे करते ना तुम? क्या करते बताओ मेरे को? मोमेंट का इक्वेशन, मोमेंट इक्वेशन इज जनरली रिटन इन द फॉर्म ऑफ y इज इक्वल टू mx प्लस c. What is y? Is a bending moment at any distance x. What is c? Is it a y-intercept? Is y-intercept is ml. Is slope is y2 minus y1 upon x2 minus x1. When you have selected m2 y2 minus y1 x2 minus x1, तो आप slope का side नहीं दोगे. Slope side will be decided automatically. So this is ml plus ml minus multiplied by l. ll cancel, and this minus will make the sign equal to minus m into x. M is common, so l minus x. This equation is correct, because if you put x equal to 0 at point A, you get mx equal to ml. At point B, if you put x equal to L, you will get the bending moment equal to 0. But if you consider any section here for calculating the shear force, there is no shear force. There is a bending moment, but there is no shear force. So shear force at any distance is always equals to 0. So shear force diagram will be simply a horizontal line. So shear force diagram is just a horizontal line, and bending moment diagram will become a triangle. So if any problem appear like this one, where the equation is given to you, you do two calculations. One is integral dA, that is the area under load diagram will be equal to total force, and then you calculate x bar, that is the position of this force from point A. And once we construct into point load, then we are able to find out reaction. So to find out area, we'll consider this diagram where we have y equal to w0 by L square into x square, and this one is x equal to 0, and this is x equal to L. If you have this type of figure, we'll consider dx consider करेंगे, and we have a vertical strip or horizontal strip, कोई भी काम करेगा. So for this one, we'll go for vertical strip. So consider one vertical strip of thickness equal to dx and height equals to y. So what is dA? Is it y into dx? So total area will be integral y dx, and the limit of integral is from 0 to L. You have y value equals to w0 by L square x square multiplied by integral dx. W0 by L square is constant. Integral of x square is x cube by 3. So what is the final answer? Check the equation of centroid. The equation of centroid is integral x dA upon integral dA. Integral dA we already solved out. So we have got 1 by 3 w0L. Let's calculate only integral x dA. Is it equal to x multiplied by w0 multiplied by L square x square dx. Integration is correct. Limit is from 0 to L. So integration will give you w0 by L square, L to the power 4 by 4. Final answer is w0 L square by 4. Now can we locate the centroid of this geometry? So we'll use the basic definition of x bar. So by definition, x bar is integral x dA upon dA is equal to W0 L square by 4 upon W0 L by 3. The final answer is 3 by 4L. By 4L from point A or point B? From point A. So we have total load equal to W0 L square by 4 and is acting at distance of 3 by 4. So to find out reaction, we'll replace this figure into point figure. So if you convert this point load, we need to find out reaction AY, reaction BY. The total load is F, W0 L by 3 at distance 3 by 4L and 1 by 4L. You can find out AY and you can find out BY by taking the moment about point A and by taking the moment about point B, or by using sigma Fy equals to 0. Try this and find out two reactions. So we have reaction at AY is W0 L by 12, BY is W0 L by 4. Now don't use this reaction to formulate the equation for shear force. Use the original figure. Point load concept is only used to find out reaction. You have to construct this figure again. And now either by using left section or right section, we can write the shear force equation. Represent one section at distance equals to x. Let call this section equals to mn and let write the equation for shear force. If you substitute for x equal to 0, naturally we will get AY, and x equal to L will get BY. This confirm? Confirm. Now at some point, are you getting the shear force equals to 0? So let's say that point equal to C, where shear force is 0. So if VC is that point where shear force is 0, can we calculate that distance x? So at point C, your value is x equal to what? L by 4. वहाँ पर आपका shear force क्या हो जाएगा? 0. If the shear force is 0, is the bending moment is maximum there? At point A, 0. What is the bending moment at point B? Is it 0? Is the bending moment is maximum at point C? So first of all, we'll write the bending moment equation. So bending moment at any point is AY multiplied by x, that is W0 L by 12 into x. Then area of this figure, which is equals to 1 by 3 W0x, and the centroid of this one is almost same as 3 by 4L, that is 3 by 4x. What is the final equation we have? So put x equal to 4 and then find out maximum bending moment. So the shear force at any distance x equal to W0 L by 12 minus 1 by 3, that is the degree is 2, so this is 1 upon n plus 1. N is 2, 2 plus 1 is 3. So height is W0. For this side, the height equal to W0 L square by x square, and this distance equals to x. We have equation W0 L by 12 minus 1 by 3 W0 L square into x cube. Now this is correct equation. Is your degree is improved by 1? So this is correct. Let's consider one point C between A and B where VC equal to 0. Substitute VC, that is shear force equals to 0, that is put this value equal to 0 and solve for x. So if you solve for VC equal to 0, you get distance x where shear force will be 0. So x equals to L times 1 by 4 to the power 1 by 3, and numerically is equals to 0.63 times L. So moment equation you have to copy down from the shear force. So this force is multiplied by what? X, and this is multiplied by what? 3 by 4 times x, or 1 by 4. No, see the section. Section is Mn. From 3 by 4 is from this side. So how much is this distance? This is load. So, and you are talking about moment Mn. So distance is 3 by 4 or 1 by 4? 1 by 4. What is the distance for AY? X. For AY, distance is x. Then what is the equivalent load? What is this load? is this load is 1 by 3 W0 x square by L square into x. So what is the moment of this one? It is x by 4. So there is a correction here. This is not 3 by 4, 1 by 4. Substitute x equals to 0.63 L and check out your maximum bending moment, and that value should. So is it a cantilever problem? This one is cantilever problem. Huh? So we have a loading equal to W equal to W0 sin pi L sin pi x by L. Entire load is above the x-axis, so we have positive area. To find out the total load, the load is symmetric, so it will act to the centroid, that is exactly at L by 2 from A. To find out total area, consider a thickness equal to dx, height of rectangle equal to y, that equal to w equal to w0 sin of pi x by L. So integral is 0 to L w0 sin pi x by L into dx. What about the integral? So if you solve this integral, we will get a total force is equals to 2 times W0 L divided by pi. Will this load exactly act L by 2? Now figure is symmetrical. This load will be distributed into two reaction, or we have only one reaction? We have only one reaction because this is cantilever. No reaction at point B because this is a free end. So is the reaction at point A equal to 2 times W0 times L divided by pi. The moment about point A also. Is the moment about point A, is this force F acting at distance of L by 2? Now W0 L square by pi, और इसके बाद if you want to write down the Vx and Mx, that you can very well write down.